Good morning everyone. I am Siksha from Chemistry Honor second year. Today I read the topic Electrochemical series of physical chemistry. Electrochemical series. We have seen that different metal ion combinations have different values of electrode potentials. The various elements can be arranged in order of increasing or decreasing value of their reduction potential. The arrangement of various elements in the order of increasing value of standard reduction potential is called electrochemical series. The electrochemical series, also called activity series, consisting of some electrodes along with their respective reductions, has been given in table 2. Here the table 2. You can see the table. Now, applications of electrochemical series. The main application of electrochemical series are given below. First, relative strength of oxidizing and reducing agents. With the help of electrochemical series, we can predict the relative oxidizing or reducing strength of substance. In the electrochemical series, the substances are arranged in the decreasing order of electrode potential, that is, decreasing tendency for reduction to occur or power as oxidizing agent. Therefore, the elements at the top of the table have maximum tendency to get reduced, and consequently, elements at the top of the table have maximum tendency to get reduced, and consequently they will act as good oxidizing agents. On the other hand, the substance at the bottom of the table 2 have lower electrode potential value, therefore they have least tendency to get reduced. Consequently, they may be oxidized and act as a good reducing agents. Table 2 shows that standard electrode potential of fluorine is the highest in the table, indicating that the fluorine gas F2 has maximum tendency to get reduced to fluoride ion, and therefore fluorine gas is strongest oxidizing agent and fluoride ion is the weakest reducing agent. On the other hand, lithium has the lowest electrode potential in the table 2, indicating that lithium has the maximum tendency to get oxidized, and hence lithium metal is the most powerful reducing agent, or lithium ion is the weakest oxidizing agent in aqueous solution. This is the substance which have lower electrode potential are stronger reducing agent, while those which have higher electrode potential are stronger oxidizing agents. Second application, calculation of the EMF of the shell. The EMF of the shell, which is difference between the reduction potential of the cathode and the anode, is determined the following step. Step first, write the two half cell reaction in such a way that the reaction taking place at the left hand electrode is written as an oxidation reaction, and that taking place at the right hand electrode is written as reduction. Step second, multiply one of the equation if necessary by suitably number to equate the number of electrons in the two equations. However, it may be noted that electrode potential E naught are not multiplied. Step 3, the EMF of the shell is equal to the difference between the standard electrode potential of the cathode and the standard electrode potential of the mode. Thus, EMF of cell is equals to E cathode minus E anode, E naught anode. The electrode potential of both the electrodes are taken to be reduction potential. Step 4. If the EMF of the shell is positive, the reaction is feasible in the given direction. But if EMF of the shell is negative, the cell reaction is not feasible in the given direction. The reaction must be occurring in the reverse direction. Thus, to get positive value for the EMF of the shell, the electrodes are reversed. Third application is predicting feasibility of the reaction. The electrochemical series help in finding out whether a given redox reaction is feasible or not in the given direction from the electrode potential value of the two electrodes. In general, a redox reaction is feasible only if the species which has higher reduction potential is reduced. That is, accept the electron, and the species which has lower electrode potential is oxidized. That is, lose the electron, otherwise a redox reaction is not feasible. In other words, the species to release electrons must have lower electrode potential as compared to the species which is to accept electrons. The electrochemical series give the increasing order of electrode potential of different electrodes on moving down the table. This means that the species to accept the electrons must be lower than in electrochemical series as compared to the other which is to lose electrons getting oxidized. Let us illustrate this by predicting the feasibility of the reaction. Cu2 positive in aqueous plus 2Ag in solid to give Cu solid plus 2Ag positive at aqueous. From the electrochemical series, electrode potential value of Cu is this and E naught value of silver is this. Since the electrode potential of Ag is more than that of Cu, this means silver has greater tendency to reduce in comparison to copper. Thus, the reaction Ag positive plus C electron gain to give Ag occurs more readily than the reaction this copper. Similarly, since reduction potential of copper is less than that of silver, this means that copper will be readily oxidized in comparison to silver. Thus, the reaction this. Therefore, silver will be reduced and copper will be oxidized, and the above reaction is not feasible, rather the reverse reaction. Fourth application is to predict whether a metal can liberate hydrogen from an acid or not. The electrochemical series can also be used to predict whether a metal can liberate hydrogen from the acid or not. Metals like zinc, magnesium, and nickel can liberate hydrogen from the acids like HCl, H2SO4, etc., while metals like copper and silver cannot do so. In general, only those metals can liberate hydrogen from the acid which have negative value of reducing potential. That is, negative electrode potential values. Obviously, hydrogen will have greater tendency to get reduced, that is, accept electrons, and the metal can lose electrons, get oxidized, and hydrogen gas is liberated. These metals are also called active metals. Metals like copper and silver have positive electrode potential value, that is, electron accepting tendencies. Their atoms are not in a position to lose electron to H positive ions of the acid. Therefore, hydrogen gas is not liberated. This can also be stated as if the standard electrode potential of an electrode is greater than 0, that is positive, then its reduced form is more stable as reduced to hydrogen gas as compared to hydrogen gas. On the other hand, if the standard electrode potential is negative, then hydrogen gas is more stable than the reduced form of the species. Now our topic of electrochemical series and their application is completed. Thank you.